let's look at example 4. We're going to find all the rational zeros of f of x equals 2x cubed plus 3x squared minus 8x plus 3. And so the first thing we're going to look at is find the possible rational zeros. So we're going to use p over q. Factors of the last term, 3, are 1 and 3. And factors of the leading term are 1 and 2. So 1 divided by 1 is 1, 3 divided by 1 is 3, 1 divided by 2 is a half, and 3 divided by 2 is 3 halves, plus and minus on all of them. Those are all the possible rational zeros. Now, if I flip over to the graphing calculator, this is showing us the graph. I've already punched in the equation here. And so if we go to the graph, we'll let it do its thing. And it looks like it does cross in a couple of places here. So I'm going to zoom in with my zoom box and just see if I can get a better idea of what some of these zeros are. Alright, so it looks like -3. It looks like a half. Just using my cursor here to get a better idea. Looks like pretty close to a half. Might be over a little bit though. And it looks like 1. So -3, half, and 1. Look like our possibles. Okay, so I look on our possibles. All three of those are possible solutions. So I'm going to work with all of them. We're going to do synthetic division to check and see if any of these are in fact 0. So let's start with -3. We'll punch in 2, 3, -8, and 3. And lo and behold, -3 is one of the zeros. So we know we've got x plus 3. And we've got 2x squared minus 3x and plus 1. Now we can finish this up one of two ways. If we look at this and realize that we can factor this trinomial, we'll go ahead and do it. This turns out to be 2x and an x. This is 1 and 1, and they're both minuses, so it does factor out. And look at that, we do have 1, 1/2, and -3 as our zeros. Sometimes it's hard to take a look at that and realize what we're dealing with. If you're ever stuck, remember, with a trinomial that you're not sure how to factor, we can always use the quadratic formula. And so we would use 2 for our A, -3 for our B, and 1 for our C. If we plug those in and solved, we would get 1/2 and 1 for our solutions. All right, so a lot going on here. Let's see if you can pull it all together and try problem 25. All right, so let's go ahead and take a look at our potential rational zeros. It's going to be 1 over either 1 or 2, which are the factors of 2. So that's plus or minus 1 or plus or minus 1/2. Only 4 choices here. So we're going to go ahead and flip this over to our graphing calculator to take a look at what the graphing calculator is doing. And if we zoom in on this, I've already entered in the equation. I'm going to hit trace, so it moves my cursor along the function, and it looks like -1 is one possible. And let's scroll over to the other place where we cross. Just while we're doing that, the -1 would have a multiplicity of 2 since it's just touching there, and it looks like 0.5 are our other options, or is the other option. So -1 and 1/2 are the two options. Those are both possibles. So let's do some synthetic here. I'm going to use -1. And so we've got 2, 3, and -1. Let's bring down the 2. And we get -1. So that is no good, since that's -2. And, oop, made a mistake. Forgot to put my x in there. X cubed, x squared, x, and then the constant. So let's see, this here is -1. And so that would be a +1, and we do get 0. So we've got x plus 1, 2x squared plus x minus 1. And let's go ahead and see if we can factor this. We've got, yep, that'll work out. If we do 2x and x, 1 and 1, and we make this a positive and this a negative. So we've got our 3 zeros. X plus 1 squared, there's that multiplicity of 2 we were talking about before. 2x minus 1, there's the 1/2 that we were looking at also.